All right, welcome back to Things Top Notch Academy. So today we're looking at differentiation. So differentiation will say it deals with a change of variables with respect to another variable. That means when you have a particular parameter, let's say x and y. So the change of x with respect to y is what we know as what? Differentiation. Just as having y equals what? X. Let's say 2x. So for you to differentiate this, you are going to get the value for y with respect to what? S. That's what differentiation is all about. And this differentiation has different methods in which we use to solve them. All right. So now these are the methods. We have first general method. So we have the first principle method. All right. So we have the chain rule. So the chain rule, we call it function of function. That's another name for chain rule. Function of function. All right. So we have the next method that we use to solve differentiation being product rule. And after product rule, we have quotient rule, then implicit differentiation. So these are the methods that we use to solve differentiation. All right. So today we're going to pick general method of differentiation. Please, if you are not interested in the general method, maybe you're interested in these 5 that are remaining, you can check the videos. I'm going to treat all of them then and keep it for you to watch and get what you want from it. All right. So, but for today's class, we're going to make use of general method. The next time we'll treat first principle method. Okay. So the general method of differentiation is a method whereby we have y equals what? S raised power n. This is the formula that we apply in the general method. All right. So you can use this to solve and you get your answer. When you are to differentiate y with respect to else, according to the definition I've given to you, so you say the y all over the x is equals to, then this n here will come down, then multiply x, then 1 will be deducted from the power will be being n. All right. So that's the method. That's how to solve differentiation by general methods. It's very simple. Okay. So now the difference between differentiation and integration, though we're still coming into integration fully. So the difference between differentiation and integration is just that integration deals with addition of 1. All right. Then differentiation deals with what? Subtraction of 1. All right. So that is just the difference. Though for integration, if you have to integrate, let's say s raised power n, so it will be plus 1, then divide by what? N plus 1. But if in the case you are asked to differentiate s raised power n, it will just be that n will multiply s, then you subtract 1 from it. So that is just the difference. So looking at the above problem, which is y equals to s raised power n, being the general method, this is the method we apply. Okay, so we asked to differentiate this, which is dy over dx, will give us n here, which is the power, will come down. So we have n multiplying, then s raised power what? N, then 1 will be what? Subtracted from the power, and that's how you solve this. So the final answer now will give us that dy over dx, being what we're looking for, is equals to n s raised power n minus 1. So this is the method. This is the way you can solve differentiation using the general method. But let's look at some examples which will help you understand this method better. Let's say we are given this example. Differentiate 3x raised to power 4 plus 2. Alright? So you may be asked to differentiate something like this, and when you are not given a particular method to use, first try the general method and know whether if it's going to work with respect to what you are given. Though it may not work for all differentiations, that's why you have these methods that you can apply to get whatever you are given to solve. Alright? So now we're given this. 3x raised to power 4 plus 2 is what we have to differentiate. So we cannot apply the differentiation method, that is a general method of differentiation, writing solution. Alright? So we are given this. Okay, so this should be y equals to, so we're given y is equals to what? 3x raised to power 4 plus 2. And we have to differentiate. So what you do now is you apply this method that I've treated here, where we have this is going to be differentiated, and also this is also going to what? Be differentiated separately, then you add them together. All right, so let this not confuse you, this addition sign that you're seeing in between them here. Can I say the y over the x? That means differentiation of y with respect to what? X, that is the y over the x, is equals to 3x raised to power 4. So 4 will come down to multiply 3. So it will now be 4 multiplied by 3x raised to power 4, which is what is there. Then 1 must be deducted or subtracted from the power, and that's what you have. Then plus, so this is a constant. So when you're differentiating a constant, it is equals to what? 0. So the value here is going to be what? 0. What do I mean by a constant? If you've not heard of constant before, you may be confused of what I mean. So what I meant is this. When you have 3x, 3x is not a constant because there's a variable attached to 3. So the value of x, or the value of the whole this, will be with respect to the value s is what? Given. So let's say s is given as 3. It means that the value of this will now be what? 3 times what? 3. Alright? Which will give us 9. So let's say s is given as 1. If s is given as 1, it means that the value here should be 3 times 1, which will give us what? 3. Can you see how the value of 3s is what? Changing with respect to the value sbs. Alright? So, but if it's a constant, there's no single change that will occur. The value remains the value. Even in millions years to come, the value remains the value, and it will never change. And that's why we call it a constant. Example of this is 2. The value of 2 remains 2. Even in thousands years to come, the value remains 2, and it will never change. And that's why we say it's a constant. And differentiating this particular constant will give you 0. All right? So let's say there's no x, or there's no variable attached to 3. You know, 3 will not have any other value other than itself being 3. Because if there's no variable that is attached to it, it means that there's no change. All right? So you can see how 3 was changing because of s. 3 here now, let's say s is equals to 4. 3 here now will be what? 3 multiplied by 4 being what? 12. And that is what we mean by what? A value being a constant. So in this case, 2 is a constant and is what? 0. Now, having done this, we can now see that the value of dy over dx is now equals to 4 multiplied by 3 is 12. Then s raised by 3, that is 4 minus 1 is 3. Then plus 0 is the same as this. So this becomes the value of the differentiation of this particular equation that is given to us. Okay, so let's solve one more example before we conclude for today's class. Let's say we're given y equals to s raised by 5 plus 3 s raised by 2 plus 3s plus 7. We have to differentiate this value or this question. So we can apply the general method which says y is equal to what? S raised by n. And you can see that this aligns with s raised by what? N. Because s here has a power of 1 and here s has a power of what? 0. That's why it's possible that you can differentiate it with respect to s. Alright? So now y equals to s raised by 5 plus 3s raised by 2 plus 3x plus what? 7. This is given. Can I get the y over the x as 5 here will come down, which will be 5 multiplied by, then s raised by 5, then minus 1, according to this. Okay? So now we have plus, here we're already having 3. Okay? Or 2 come down, multiply by 3 we're already having, raised by 2 minus what? 1. You see the same as for this. This is having a power of 1. 1 should come down, multiply 3s raised by 1 minus 1. Then, remember, this is having a power of 0. Okay? So if 0 comes down, let's say we're having 7s raised by what? 0. Okay? You know this is the same as this. So if 0 comes down, so it will be 0 multiplied by 7s, which is the same as what? 0. And that's why I told you that when you differentiate a number that is a constant, the value becomes 0. So instead of us going through all this process, it's better we just write 0. Okay? So now we have that dy over dx is equal to, then this is 5s raised power 4 plus, then 2 multiplied by 3 is 6, s raised power 1, and there's no need writing 1 again. Then plus 1 times 3 is 3, s raised power what? 0. Then plus 0 is same as 0. Remember, any number raised to a power of 0 is the same as 1. So having s raised to the power of 0 is simple as multiplying 3 by what? 1, which is the same as what? 3. And this is the what? Differential form. Okay? Alright. That's how to solve this. please, if you're not interested in this general method, that you're interested in any of these methods, please do well to check other videos. You get the solution to all these methods. All right. Thank you and remain blessed.